A screw is an inclined plane wrapped around a cylinder. During the manufacture of a screw, the inclined plane is tooled so that it spirals around and protrudes from the shaft of the screw. The resulting feature is known as the threads of a screw. Screws are used most often to hold things together. The pointed tip is inserted into an object and a force is applied to turn the screw. As the screw turns, the threads cut into the object and pull it up the shaft of the screw. Like other simple machines, screws change the direction of the applied force, thus using less force to do work. And like all simple machines, there is a trade-off. The force must be applied over a greater distance. The focus question for this activity is, how does the screw reduce the amount of force it takes to pierce a piece of wood together? In Activity 11, students are introduced to the sixth type of simple machine, the screw. This activity will take about 40 minutes. The vocabulary introduced in this activity is cylinder, screw, and thread. The materials that you will need from the kit for each student include a nail, a screw, 2 pieces of string 30 centimeters long. Because the students are going to be putting nail holes and screw holes into the balsa wood that is provided in the kit, we suggest that you also use the safety glasses that are in the kit. Teacher-provided materials would include, each student will need a nail. They will need to have crayons, scissors, a dual-scale ruler, hammer, and a screwdriver for the class, and you're going to need some transparent tape. Duplicate Activity 11 sheets A and B. Let me just tell you about this sheet. This sheet has a screw pattern on the back of it. What you will need to do is make one of these per group of 4. When you duplicate this sheet, enlarge it 110% so that you will eliminate the border around the black line master. Begin this activity by giving every student a screw to observe. Ask why screws are used, which is to hold things together. Call attention to the ridges around the shaft. Introduce the term threads. Ask student to explain the use of the threads, which is to grab or pull the wood up the shaft. Making a screw harder to remove than a nail. Point out that the threads are what make the screw related to the inclined plane. Give the student groups the screw pattern, pencil, tape, crayons, and scissors. Direct each student to cut out the screw pattern piece. You may have already done this ahead of time. Have students place the triangle on the desk with side 2 parallel to the desk edge. Students should recognize that this would be what, Kathy?
It looks like an inclined plane.
It sure does. Direct students to color a thick line along side 3. Kathy, we're going to let you choose the color you wish.
I think I'll take red.
Okay.
And I'm going to put this piece of paper under here so they don't color on the table or the desk.
Right. They can help each other.
It doesn't have to be a real thick line, but we don't want them coloring the whole paper.
Okay. Then you're going to give each student 2 pieces of tape. So Kathy, why don't you go ahead and break 2 pieces of tape off. Okay.
Okay.
Now they're going to tape side 1 along the pencil. All right, so we'll go ahead and put a piece of tape.
Just right there.
Yeah, let's do right here in the middle. I think that will be fine. Ask what the pencil would look like if they wrap the paper around the pencil so that the colored edge shows. It looks pretty much like a screw, doesn't it, Kathy?
Wow, that's really cool.
Yeah, ask students to compare the wrap pencil to the screw. Then invite them to observe that both have spiral markings along the shaft. Explain that the threads of the screws are a long, single inclined plane wrapped around a cylinder. Then introduce the term cylinder as a round, tube-shaped object. Ask the students to respond to question 1 on their activity sheet. At this point, you're going to distribute a nail and ask the students to compare and contrast the nail and the screw. Both have a flat head and a pointed tip. The screw has a slot in the top of the flat head. Kathy, let's do some investigating here about the amount of force and the direction of the force when we put a nail and a screw into the wood. And the teachers will be demonstrating this. One of the things that we encourage you to do, again, is to talk to the students about being safe with the tools. If you'll notice, ahead of time, you should have already put some slight holes in the piece of wood as starter holes for the nail. So Kathy, let's go ahead and let you, just as we would the students at a demonstration table, put the nail into the wood. How would you go about doing that?
Okay, I would wear my safety goggles, but I'm already wearing some, so
okay, yeah, those safety goggles are really
we want the
important.
teachers to be sure to model that. So,
okay.
Right, I'm going
to... okay, then you would ask the student, talk to me about the force and the direction that you used to get the nail in the wood.
Well, it didn't go in easy. I had to hit it pretty good to get it to go down, but it went down in the wood.
So it was a downward force, and you had to use quite a bit of force to get it in. Now what I'd like for you to do is let's look at, and you'll be inviting the students, they'll have a chance to do this as well, to put the screw into the wood, about equal distance. Okay. What kind of force did you use, Kathy?
Well, I made a downward force.
Okay.
And a clockwise motion to get that in. But it was pretty easy to do.
It wasn't much easier.
Yeah, it felt a lot easier to put the screw in than it did the nail.
Okay. Let's see what you would do to get the nail out. What kind of force would you use? Came out. What kind of force did you?
I did an upward force to get it out.
So a pull.
A pull.
Right, but you could get it out. Now let's see if you can get the screw out by doing the same.
Oh, no, that's not going to come out of there.
Right. The threads on the shaft really ate down into the wood or pull the wood up to them. Let's see then how you would go about getting the screw out.
I could probably use my fingers, but I think the screwdriver...
That would maybe be a little bit difficult too.
Yeah, that's really easy.
Oh, that wasn't hard at all.
No, that was not.
Okay. So the force used to get the screw out of the wood, what would you conclude from that?
Well, it was a counterclockwise upward motion.
Okay. But it took a little longer to do it.
Definitely.
Definitely, rather than just pulling out. So at this point, you're going to talk to the students about the trade-off when using a nail or a screw. A screw takes a less force, but must be applied over a greater distance. In the final part of this activity, students will be able to see the trade-off of force for distance. To do this, Kathy, we're going to compare the measure of the shaft of the nail and we're going to the shaft of the screw using a string in both times. Now what we're going to do is I'm going to get the length of the nail And because the threads are wrapped around this shaft, you're going to use string to wrap the string around the shaft and compare the length of the straight shaft with the screw shaft.
Okay.
Okay? So
I'm going to start at the top of this, and then I'm going to
start
get
at
it in
the
the
top
grooves.
and put it in the grooves.
I'm already thinking this is going to take me longer than you.
Well, but let's just recap what the students have responded to on their activity sheet. They learned that it was easier to drive the screw in the wood, but it took a longer period of time. So they concluded that screws will make work easier. It just takes a little bit longer. All right?
Oh, wow, that's a lot longer, isn't it?
Oh, my. Look at the length. So once again, the students you'll discuss with the students what the trade-off is for using a simple machine, which is, Kathy?
Well, it was a lot harder to get the nail in than it was to drive the screw in. But look at how short that is. I mean, it took a lot less distance to get the nail in than it does the screw.
Once again, students should conclude that when using a simple machine, there is a trade-off of force for distance. During cleanup, let students keep their paper screws, discard scraps of string, collect all other materials, and return them to the kit. Put the tools away in a safe place. Now it's time to read page 11 in the Delta Science Reader, the article called Screw.